All right, let's try this one more time. Hopefully it works this time. So this is kind of stuff that you've learned probably in Algebra 1, definitely in geometry, and it's called, first thing, it's called a Cartesian plane. I'm not going to really get into it because we talked about it last year, but it's named after a person. It's named after a man who lived in the late 1500s, early 1600s. Here, I'll write it down. I put it in my notes, so I'll include it here. From 1596 to 1650. So in the course of all of history, that wasn't all that long ago. He's a lot more current than Pythagoras. Remember Pythagoras, Pythagorean theorem? He was around before Christ was. All right, so this guy came a lot later. And it's called the Cartesian plane, or sometimes they call it the rectangular. You'll see it a couple different ways. Rectangular coordinate system. So that's a little wordy. René Descartes was a Frenchman. Oh, I didn't put his name. I'll put his name. I always like to do that. Give you a little bit of history. And this is how you spell his name. This is why they call it the Cartesian plane, because of this part right here. All right, the cart. In French, they don't, I guess, I don't know anything about French, but at least in this situation, the S's are silent. All right, so it's just Descartes, René Descartes. It is a man, even though in America that would normally be a girl's name. In France, that's definitely a guy's name. A lot of guys named René in France. So that's a little history about this. What is it? Well, it's something that I'm sure you all recognize. Remember this? Let's go over it very quickly. All right, you got these two lines, they intersect each other. Okay, this one's horizontal. What do we call that line right there? The X what? Axis. All right, this vertical one is called the Y axis. All right, you got these blocks. See how it splits it up into 4 different areas? You got this one, this one, this one, and this one. Okay, what do we call those things? Quadrants. Good. Yeah, so this is nothing new. So it's just review. And we number the quadrants. Which one is the first quadrant? We number them 1 to 4. Top right one. That's the first one. Then which direction do we go? Yeah, let's say clockwise, counterclockwise. Counterclockwise, right. You go the opposite direction. A clock goes this way. Of course, nobody knows how to read a clock anymore, it seems like. So clockwise is probably not the best way to describe it anymore. But if you go to the left, or that's counterclockwise. So that'd be 2. This would be 3. We use Roman numerals. Don't know why, but they do. All right, they use Roman numerals, easy enough. Where do we start? Like if I was going to put a point somewhere, we got to start somewhere. Where do we always start with this? Anywhere on the x-axis? At 0, 0, which is called the what? It's the origin. Good. See, this is very familiar stuff to you, I would think. So that's the origin, and somebody already said it's 0, 0. Let's talk about that a second. That thing right there with the parentheses and the comma in between, we give that a name. I'm just doing this so that we're on the same page, all right? So when I start saying these names and these words, everybody knows what I'm talking about. So they're called ordered pairs, or just an ordered pair. An ordered pair is an X and a Y. The X always goes first, the Y always goes second. If you want to be, I didn't do this in my geometry class, but if you want to be really specific on this, I don't really care if you know this, but this is called the abscissa, A-B-S-C-I-S-S-A. It's kind of weird spelling, abscissa, and this is called the ordinate, O-R-D-I-N-A-T-E, ordinate. All right, I don't care if you know it. It's not going to be on a quiz or test, but it's in the book, and some people think it's important, so that's what we'll talk about that. Notice, it is an ordered pair, so it can't go YX. The X has to be first, okay? Just like alphabetical order, X comes before Y. So it's in alphabetical order, the X has to be first, and the Y has to be second. All right, so if I wanted to plot a point, it seems like books don't say plot anymore. It seems like they say graph. But I'll probably use that word a lot, plot a point. If I plotted it, that means you put the point where it's supposed to go, all right? And let's do this in a different color. In the other class, it was all white and everything got mixed up. So I'm gonna put some numbers. If I go to the right of 0 on the x-axis, what kind of numbers are they? Positive numbers. And to the left, negative numbers. If I go up on the y-axis, what kind of numbers? Positive. And if I go down on the y-axis, negative numbers. Okay? So it's positive in this direction, negative in this direction, positive in this direction, negative in this direction. All right. Let's actually plot a point. So what if I said graph or plot? Again, I don't know what word they use. My guess is they use graph. Let's just say, let's go easy. Let's go 2, 3. So if I ask you to graph the point 2, 3, and a lot of times we'll put a letter in front of it. Okay, so call it point A once we find where it's located. So where do we always start? At the origin. The origin, that's the beginning. Origin means beginning, okay? So we start here and we go in the x direction first, and then we go to the y direction, all right? So we start at the origin, always start here. We go 2 in the x direction. It's a positive 2, so we go in which way? To the right. So we go 2 places. Don't put a point just yet. Just keep your pencil there. And then we go what? 3 up. All right, so 1, 2, 3. Then we can put a point. And what are we going to call that particular point? Call it point A. All right, let's graph another one. I'm not going to graph in every single quadrant. We'll just do a couple of these. What if I said -4, 1? Okay, well, where do you start? Start at the origin. We go, don't say over, go to the left. How many? 1, 2, 3, 4. And then go up 1. And we'll call that point B. There it is. You with me? Let's do one more, but let's do it a little different. Let's do one right here. What if I put a point right there? Now, this time, you tell me where that point's located.
0, -4.
Very good. Okay, because you start at the origin and you go in the x direction. To get to this point, do you go in the x direction to get here? No, you don't go anywhere this way, all right? You just don't go anywhere, which is 0. And then you go in the y direction and you went down, how many places? 1, 2, 3. So 0, -3. Everybody okay with that? Simone? Yeah, just draw lines. Yeah, I mean, these aren't going to be like so detailed, right? Just draw a line. It'd be nice if you had a ruler, right? You made it kind of straight, or take another piece of paper, fold it in half or something. Use some kind of a straight edge. It would be nice. I'm not going to mark any points off for that. On a quiz or a test, I'll probably give you the graph on the quiz and test, right? On the answer sheet. Did I do that for the last one? Yeah, I think I did. Did we do graphing already? Oh, I gave you that straight number line. Yeah, that's right. But yeah, I'll give you one like this, and it'll probably look more like this thing right here. All right? So I'll give you a little box with all the grid marks on it, and then you know how many to count over and that kind of thing. But on your homework, yeah, just draw it. It's fine. These aren't going to be super picky. All right, now what we're going to do. We're going to talk about that ordered pair. All that just to set us up for this next little thing. This is something that you probably, how many times have I said this year, you probably did this in Algebra 1. I probably went dozens of times. Would you agree? Maybe up to or past 100 times. I said you probably did this in Algebra 1. This stuff you probably did not do in Algebra 1, is my guess. So I think this is going to be kind of new for you. All right, so, I had an example on here. It's just easy. I just give you some points, and you have to plot the points, right? I kind of already did it for you, so I'm going to skip that example 1. But now I'm going to go to this thing called a relation. Now, it's not like, your mom and dad, your cousin, your uncle, anything like that. Okay, this is a little bit different, all right? And here's the definition. It's very, very simple. It's any set of ordered pairs. Any set of ordered pairs. So anytime you have an ordered pair, that's considered to be a what? A relation, okay? Now, we're going to do another word a little bit later, but we're going to talk about relation a little bit before we get to the next word. It's any set of ordered pairs. So if it has an x and a y, it's a relation. So let me just show you some things just to lead you up to something else that we're going to do. I'm going to put a little table right there. Do you remember doing this in Algebra 1? Is that 101 times now that I've mentioned Algebra 1? All right, so I'm sorry. But you did this when you first started plotting points. All right, so I'm going to go 1, 3, 3, 5, and then I'm going to go 3, -1, 2, and 4. So the 1 goes with what? With the 3. The 3 goes with the -1 and so on. Everybody got that? It's not just in some random order. Okay, these go together to make a what? An ordered pair. Right, so that means 1, 3. That means 3, -1. 3, 2. That's not 2, 3. It's 3, 2. Order makes a difference. And then 5, 4. That's what this means right here. Everybody understand that? What we're going to do is we're going to talk about a name that I don't think that you've talked about before, and it's called domain and range. Have you done that before? You have done domain and range? All right, well, there you go. We're going to do a lot of this. All right, so the domain is I'll tell you what, I'll do it like this. I'll do it like an ordered pair. The domain is basically the x value, all right? And the range, what do you think the range is? The y value, that's right. So the domain are your x numbers and your range are your y numbers. So they're going to give you something like this. They could give you ordered pairs. They could give you a table. They could even give you a graph, right? Let's just graph this. We'll do it kind of sloppy. It's not going to be super, thank you. It's not going to be super detailed. So 1, 3, so let's go. Well, it goes to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You just put it on the table somewhere. All right, good enough. All right, that goes like that. You get the idea. So let's plot these. 1, 3. 1, 3, right there. 3, -1. There's 3. There's -1. 3, 2. 3, 2, right here. 5, 4. So there's 5, and there's 4 right there. And there you go. So there's my points. Everybody see that? All right. So they could give you a table. They could give you a bunch of ordered pairs. They could give you a graph. All right. And they're going to ask you to find the domain and the range. Very, very easy. All right. Because the domain are just the what? The x values. And the range are the y values. But they want you to write it a certain way. All right. So watch. There's a couple rules, I guess, for this. How come I not remember? 5 after. Okay. Domain is, now watch what they do. They put a little brace thing right here. They always do that for domain and range. So learn to make that little squiggly brace thing. And then we list all the x values, but we want to make sure we list them in order. And if there's any repeats, we just list it once. Okay, do you hear? So first of all, we put them in numerical order. So this is already, the x values are already in numerical order, aren't they? 1, 3, 3, 5. But we're not going to put both 3s in there, are we? We're just going to put 1, 3 in there and then 5. Because they just want to know what numbers are in the domain. All right? 3's in there. It's in there twice. But you listing it, you don't have to put it in twice. All right? But it is in numerical order, isn't it? 1 comes first, then 3, then 5. Okay, what's the range going to be? So we do the little brace thingy. Right? And let's list the ranges. But what did I say at first? We want to put them what? In order, numerical order. So what's going to go first? -1, then 2, then 3, then 4. And then you close it up like that. Pretty easy. It's really not that hard. Anybody could do it. Would you agree? A lot of times you'll see it like this. They love doing this. I guess I could see the usefulness of it. But they put it like in a circle. Mine's more oval, but they probably use it more of a circle look. And then, so there's your domain in the first circle. What's the range? -1, 2, 3, 4. And I'm going to show you what they do here because it really can be helpful to us. I'll just do this. Okay, so do you remember I said the 1 goes with the 3, and this 3 goes with the -1, and this 3 goes with the 2, and that 5 goes with the 4. So what they do is this. they say the 1 goes with what? Does this 1 go with the negative 1? No, it goes with the 3. So I just draw a line or an arrow from 1 to 3, just to show that that one goes with the 3. You okay with that? Well, they'll show it like this sometimes. Okay, so I want you to be able to take this picture and understand what it means. And I want you to be able to tell me what all the ordered pairs are. Because 1 goes with 3, so what's my first ordered pair? 1 what? 1, 3, right? And then they'll show you another one. Let's see, the 3 goes to the negative 1. All right, the 3 also goes to a 2. And then the 5 goes to with a 4. Everybody see that? Because there's only 3 numbers here, 4 numbers here. They got to match up, right? So this one actually goes with 2 other ones. Now that right there, what we just did, when one of the numbers in the domain goes with 2 numbers in the range, that's going to mean something. All right, I'm not going to completely give it away. You're right. Okay, this means something. All right, we'll talk about that in a little bit. So that's the kind of stuff that you're going to see. So here's an example. Everybody's okay right now, right? Hasn't been so hard. Looks a little weird, but yeah, it makes sense. So this says, this is way too easy. It just says, represent this relation, and they call it E. They put a capital letter. So they do the circle thing, all right? So they go negative 1, 1, 3. They put it in a circle. And then they go negative 3, 1, 5. They put that in a circle. And they put some arrows in here. And this is a very easy situation. There's no crossing. That goes with that goes with that, and that one goes with that one. So what do you think they're going to ask you to do? They're going to ask you to represent it in a couple ways. They say represent it as a set of ordered pairs. Ordered pairs. And then represent it, part B, as a table. That's that little T thing, right? With the X and a Y. And then represent it with a graph. And then they're going to ask you to find the domain and range. This is actually very simple, okay? Don't overcomplicate this. This is basic, elementary kind of stuff. Not elementary school, but basic elementary Algebra 2 stuff. So represent it as an ordered pair. So the negative 1 goes with what? Negative 3. They're not always going to be this easy. Sometimes they'll cross, right? And that kind of thing. So what's the next ordered pair? 1, 1. The next one, 3, 5. Easy. There you go. So you did that. Represent it as a table. So we do this. Put an X and a Y here. What's the X's? Negative 1, and then negative 3, 1, 1, and 3, 5. Easy. Represent it as a graph. So you just plot the points. All right? Negative 1, negative 3, right there. 1, 1 is right there. And then 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 is right, about right there. There you go. And that's what they ask for. And then they also ask you to find the domain and the range. I'm going to show you another way that they write this. You could just put the braces, because this is something you're going to see later on, and you just want to get used to it, all right? It's kind of weird that they do it this way. I don't understand really the reasoning behind it, but this is what you'll see a lot. So you could just put domain equals braces, negative 1, 1, 3, correct? And then range equals, put the brace, negative 3, 1, 5, boom, easy. Right? But this is a little bit, they call it, I don't think I've ever heard this before, but this book anyway, calls it the set builder notation. I think there's other names that other people call it, but you will see this a lot in, when you start getting out of Algebra 1 into a little bit higher math. So here's what they do. They start off with the brace. It's not much different, okay? And then they say this, since the domain are all the x's, they put it x. So what this is saying is this, the domain is, or equals, the set of all x's. That's what that x right there means. It's the set of all x's such that, we actually have a symbol for such that in math. You see it so many times. So it's just an up and down line. That up and down line means what? Such that, okay? It's weird. All right? So this means what? The domain are all the values of x such that, and now we have to give some restrictions. What's, in this situation, what are my domains? Yeah. Let's just say, yeah, you just list them. -1, 1, and 3. And then you close the brace. All right? It's kind of weird. It's a little extra, don't you think? Yeah, I mean, why can't you just stick those numbers inside of the braces? I don't know. But you'll see it a lot. I just want you to get comfortable with it. Now, what about the range? Are you going to say all the x values on range? The range are all the what? The y values, such that, all right, and then you just put the numbers in for the y. So it's -3, 1, and 5. So that's your restriction for your range. And that's the kind of stuff that they're going to ask you. Let's get that was super easy. Let's get to one. It's not difficult, but it's a tad more, all right? Yeah, example 3. It says state the domain and range, so I'll write that down. State, I'll just put D, is that all right? The domain and range of each of these relations. So here's part A. They give this relation a capital letter for the name, and they give you, remember what a relation is. It's just a set of ordered pairs, right? And 2, 4. It takes me longer to write out this problem than it would to even come up with an answer. All right, so those are all the points in my F relation, okay, the relation F. So it asks for what? The domain and the range. So domain is equal to, it looks like, yeah, we'll do this. I don't know if when it's just a bunch of points, I don't think you have to do that whole set builder thing. They're not doing it here. So I'm just going to put the points. What is my domain? First of all, go in numerical order. So it's what? -2, 0, 2, and 4. Yeah, easy. It was already in numerical order. At least the x's were. And then the range. Whoops, that's an ugly old brace. I was trying too fast. That's not so much better. Look at it. 4, 4, 4, 4. So what do? Do I put all 4 of those 4s there? No, it repeats, so I just put 1 4 there. All right? And that's that. Now, it says, nope, that's just part A. That was easy. No biggie. Now it gets a little bit more involved. Here's part B. And this is what they give you. They give you a graph. All right? And 1, 2, 3. 1, 2, 3. All right, so they give you this point right there. Now watch, now the next one's going to be a little weird. So it's now watch what I do here. They actually put an open circle, and then they connect like that. Okay? So what I want to do is figure out the domain. Now, it's a straight line, right? So we're not just doing integers like we did before, right? -1, -2, 3, 4, 5, all that kind of stuff. Now, it's every single number between one point and another point, okay? So let's take a look. Let's talk about the domain right now. The domain are all the what values? The x values. Now, this point right here would be what? -1, -3. Agreed? So where does it start as far as the x's go? Forget the y's right now. Just the x's. This red, it's like a line segment, all right? Where does it start on the x-axis? No, not at -3, that's the y-axis. Along the x-axis. Along the x-axis is the domain. Where does this point on the x-axis? No, 0 would be here. It's at -1. Look right below it. Do you see it? All right, that's the x. And where does this one end? Right there. So it's between here and here. What is this point? -1. What's this point? Almost put a negative. +2. Everybody see that? So from here to here is your domain. But does it include -1? Why not? Because the open circle. But it includes every single number in between all the way up to what? To 2 and including 2. All right? So here's how we write it. You've seen this before. X is between. Have you seen that before? Did we do this in the last chapter? I think we did, didn't we? I don't know. I get confused between this class and the pre-calc class. So what's my first number then? -1. And look, do I put an or equal here? No, because it doesn't. The domain does not include -1, but it includes the number just to the right of -1. All right? I don't know what that is because it could be no, it's not 0. It could be negative point what? 9999999, right? Okay, really, really close to it, but it's not just 0 because look, all these are numbers in between, right? They're not just integers we're dealing with. Then it goes all the way up to what? To 2. Does it include 2? Yes, it does because it's a darkened in circle, right? So I put or what? Equal to. That's how you write your domain on a graph like this. When it's a line, they're not just points, okay? There's a bunch of points, okay? And an infinite number of points between here and here. That's your domain. What's your range? Well, I'm going to put a y, and if it's between something, I always do this, okay? And so what's your lowest y value? It's -3, but it doesn't include -3, does it? But see, that means it does not include. It means it's everything just a little bit bigger than -3. What about on the y-axis? What's the upper limit to it? It's +3. So I put a +3 here. Does it include +3? It does because it's colored in. So that's your domain and that's your range. I told you it was a little bit trickier than the other ones. All right. Now, if you wanted to write it in that set builder notation thingy, let's give this a little more room. Here's how you would officially write it. Now, if you didn't write it like this, you probably would not mark off, but I just want you to be familiar with it. All right? I want you to be able to see it, so when you see it in the book, you're like, oh, that's what they're doing. Because if you just saw it, you're like, what in the world are they doing? Why do they do all that stuff? So how would we do this in the set builder notation? We say the domain are all the values of x, what? Such that, and then you just go on and list your domain, right? X is restricted. What's it restricted? Between -1 and 2, but it cannot include -1. Then we close off the brace. So that's the kind of way that you're going to be seeing that in the book. All right, so don't let it scare you. It's really not that big of a deal. So all the values of y such that all that stuff is true. All right? So you probably haven't seen that before is my guess. Would you agree? I don't know. Have you? Probably not. All right, there it is. All right. Don't let that scare you off because I'm not going to force you to draw it in that notation. Now here's another type of graph. I kind of doubt you did this in Algebra 1, but this is definitely something we're going to learn how to graph later in this class. So watch. It was supposed to hit right there, but it doesn't make any difference. This is actually called a hyperbola. And what we want to do is what? Find the domain and range. Domain and range. Okay? So the domain, how can I start it off? Put the brace thing. Domain, all the x's such that. Okay? Now look at this graph. It's kind of weird. It's supposed to hit right there at 0, okay, just so you know. what are all the possible x values for that graph? Just all the numbers? All the positive numbers, and what else? Including 0, because I was supposed to hit it right there at 0, okay? So all the positive numbers, including 0. Is 0 a positive number? No, 0 is just 0. It's not positive, it's not negative. 0 is just 0. So the domain are all the numbers that are what? I'm not going to just say positive. I want to write it in terms of x. X is what? Greater than or what? Or equal to 0. And that's how you would write it. You see what that means? This means all the values of x that are greater than or equal to 0. Because look, every single one of these points has an x value, doesn't it? Are there any x values to the left of that? No. It's just to the right. So every single one. This even has an x value, right? This has an x value. All these numbers. And with the arrows, this just keeps on going forever. So every single number greater than or equal to 0 could be included in this graph, right? What about the range? The range is up and down, right? The y. So y such that, what do you think? Everything. That's right, because look at the y value. Look, this keeps on climbing, doesn't it? This keeps going down, 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 down. And it includes everything in between. So it includes all the, what do we say? The real numbers, okay? All the real numbers. And how do we write that in math? We put that crazy looking R, all right? So that's the way you'd probably want to write it. If you just said all the real numbers, I'd give that to you if it was on a quiz or a test or something like that. If I asked for the range and it was all the real numbers. If you wrote all the real numbers, that'd be fine. But this is kind of the way they do it. All right? And I believe, wow, we did. I got to what I wanted to get to. So everything that we've dealt with right now is just about what? Relations. Okay? Tomorrow, well, not tomorrow because I think we got pep rally tomorrow, but probably Monday. We are going to talk about another thing. Mia already said it. She's probably already learned this stuff. Are what? Functions. It's similar but different, okay? Similar but different. And we're really going to talk more about functions than anything else, okay? Because everything is a relation. Every ordered pair is a relation. We're going to talk specifically about functions. So, let me see. I'm not officially assigning this, okay, but it's 1 to 22 because I think there might be some function stuff on here. But do everything that's on 1 to 22, but when you see something that talks about a function, don't worry about that because we haven't talked about it yet. But you could probably do a handful of these, all right? So do everything that just talks about relations. Once it starts talking about functions, forget it, and we'll deal with this the next time we meet, okay?